My name is Susan McKeever. I'm the head of the Data Science and Artificial Intelligence discipline in TU Dublin. So the project that we're undertaking is using in-situ Wi-Fi in order to be able to detect human activities in a space, so in a room. So without the use of sensors or additional sensors, using the Wi-Fi signals to know what's going on. So what's interesting about this project is if you use Wi-Fi, you're using in-situ sensors, if you like, where you are not having to carry anything extra and where you can, in an inexpensive way and a non-invasive way, you can do sensing, such as, an elderly person in their home, in a way that's not invasive or blatantly invasive to them. The premise behind it is that when you are in a space and there are Wi-Fi signals around, by virtue of you being in the space, and if you're moving or if you're not moving, you're interfering, if you like, or you're changing the Wi-Fi signal in space. So the idea is that there's a pattern around that. So if you stand up in your space and there's Wi-Fi there, that pattern of how you interfere with the Wi-Fi signal as a result of sitting up will have some sort of pattern that you can discern. So you can then treat it as a pattern matching problem, how to discover the pattern, which of course is straight into machine learning. So we want to use deep learning in order to create models that can detect human activities in a space using the in-situ Wi-Fi signal. This project has a number of different applications, because if you think about it, of the spaces where you might want to know what's going on in a space without people having to be sort of censored up. If you think about the kind of use cases for this, you could use this, for example, in hotel rooms, you could use it in prisons, you could use it in hospitals, you could use it in people's homes if there's a vulnerable person living in the home. There's so many spaces where you might want to detect the state of activity or retrospectively the state of activity, whichever, real time or retrospective, as to is there somebody in the space and what are they doing? So there are, endless use cases, but it only really works if you resolve the domain problem. Unless it can transfer, it's quite hard to make this a practical usage, and that's why we're going for that particular problem. The innovation of the project is that we're going to look at how you take a model that's developed for human activity recognition from Wi-Fi, and you take it and you move it into another space and it still works. So there are plenty of people using Wi-Fi signals to detect human activity, or to do HAR as we call it. There are plenty of people doing that. The problem of course arises is you don't want to have to retrain a model when you go and move it into a different space, or with a different person in the space, or in the same space but you move the furniture. All of these things are all part of domain change, as we call it. So the exact problem we're addressing is how do you make adaptive models that can switch from one domain to another without having to go through a problematic or expensive process of retraining? How do you make models that can adapt to new domains? Once we get to the end point of this, where we've got a sufficient inroad into the domain adaptation problem, at that point it starts to get interesting, because potentially it's a project that you could look to commercialize. And depending on the extent to which that domain adaptation is solved, the next step is to see how do you bring it out into the real world. So that's definitely something we'd like to look at.